All right, welcome to Notes 1.3b, functions and their graphs. So we're sporadically reviewing some of these functions if you haven't noticed throughout these days, like we added absolute value, piecewise. So we're going to be reviewing greatest integer function, and it's also called step functions. It's showing that there are values here, but they're set within their own domain. So like the domain of -3 is from -3 to -2. The domain of y equals -2 is from x is from -2 to -1. And so this is called a step function, or also called a greatest integer function. The graph of it is the domain is actually from -infinity to infinity, because as you can see, it's closed here to open, and we're actually closed there. So it actually covers everything, but it does it in steps. The range is the step of the integers. So whatever your lowest integer would be, so like -3, -2, -1, 1, 2, 3, 4, or whatever it is in your graph. Your y-intercept is still 0, 0, and it's constant between each pair of consecutive integers. There's no increasing or decreasing. It jumps vertically 1 unit at each integer value. So that's just a little bit of a review for some of those parent functions. And now we're jumping into sketch the graph of this piecewise function by hand. So our split is going to be at 1. And so what we could do is we could plug in, or we could even just graph this line, since we know how to graph a line. If you're not sure, you could plug in the values. So we know we're starting at 3, and our slope is up 2 over 1. And we go to 1, and then everything less than 1. But we have that closed dot at 1. So down 2 over 1, down 2 over 1. And this line is going downhill. Next, everything greater than 1, -x plus 4. So we have two choices. We could just graph it, or you could plug it in. You could graph it and then figure out where we would end up, because this one starts at 4. We go down 1 over 1. So we know our first point at 1 is going to be at 3, but that's going to be an open circle. And we know our slope is -1, so we keep going down 1 over 1. And we have our piecewise function, both on each side. If you didn't want to graph the line just by doing the y-intercept and the slope, you could have gone in and actually plugged in your x values to figure out what those were. Okay, next we have some graphs here. We're talking about even and odd functions. So an even function is symmetric to the y-axis. This is an example of an even function, because if we plug in -x, we get y. If we plug in x, we get y. They're the same thing on each side of the y-axis. It's symmetrical here. If we have something symmetric to the origin is that center point, it is an odd function. And what's different about this is if we plug in x, we get y. If we plug in -x, we get -y. So they mirror each other, those points, across the origin. The last one, this one is symmetric to the x-axis. This is not a function. There's a lot of not a function examples, but even functions are symmetric to the y-axis, and odd functions are symmetric to the origin. Anything symmetric to the x-axis is not a function. Okay, so now this one's asking us to determine whether the function is even, odd, or neither. So this one is symmetric to the y-axis, so this would be an even function. This one is symmetric to the origin. You can see that if we put a mirror there, it's going to be symmetric to it. This one is odd. This one, if it was centered at 0, 0, it would be even, but it's not. So it's actually neither. This one is actually symmetric to the y-axis. Even though it's shifted down, it's still symmetric on both sides. So this one is also even. Okay, so just like we talked about there, you can look at them from the graphs, but if a function is even when the domain of f, so if f of -x is x, if we plug in -x, we get x. It's odd if we plug in -x and we get a negative function out front. So determine whether these ones are odd, even, or neither. For these ones, we actually have to break them up and do it algebraically. So we have x cubed minus x. So to determine whether it's even, odd, or neither, plug in -x, and we'll see what we get. So we go -x cubed minus negative x. Let's see. Negative x cubed would be negative x cubed, and then negative negative makes a positive. This is the complete opposite of that function, and so it would actually be negative g of x. And so this one, therefore, would be odd, because they're the opposites there. So let's plug in this one. Negative x squared plus 1 for b. Negative x squared would just be x squared plus 1. This gives me the same function again. That just gives me h of x. So that tells me that this function is even, because I got the same thing. Okay, x cubed minus 1. If I plug in negative x, I am going to get negative x cubed minus 1. This is not the complete opposite of the function, but it's also not the same function, so it would be neither. Thanks, guys.